Hi Year 9s, welcome to the new school year, and welcome to Year 9 Science. This is our very first topic. We would have had a little bit of an introduction in class or via Teams talking about how all of this works and doing science right and where to find these videos. Obviously you found it because you're watching the video. This is the first unit. We're looking at the atom, and it's a chemistry unit. We're going to start by doing a bit of a refresher from Year 8, looking at the periodic table. I'm going to start by looking at basically what is the periodic table. So you would remember from Year 8 that when we're talking about elements, elements are organised in the periodic table by their atomic number. And that atomic number stands for how many protons are in each atom. So for example, if we go along, the very first element we look at in the periodic table is hydrogen. Hydrogen has an atomic number of 1, and that means it has 1 proton in its atom. As we move along, number 2 is helium, atomic number 2, 2 protons in its atom. We keep going on, 3, 4, 5, 6, 7, we get to 7, which is nitrogen, atomic number of 7, 7 atoms in its atom. 7 protons in its atom. And this continues moving all the way down the periodic table as we go across each row, called a period, which we'll talk about in a second, and then go down when we get to each end of each period, we go down to the next period. We keep getting larger and larger in terms of atomic number and how many protons are in the atoms of those elements. Now, talking about how the periodic table is actually structured. So as I mentioned, these rows are called periods. So period 1 consists of hydrogen and helium. Period 2, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Period 3, period 4, period 5, period 6, period 7. Okay, so that's how you remember the periods. Now if we're going on to groups, the groups are going down. So we have group 1 with hydrogen, starting with hydrogen going down. Group 2 starting with beryllium going down. We don't worry about these for the time being. Then we go group 3 starting with boron moving down. Group 4, group 5, group 6, group 7, group 8. So way of remembering this, okay, the rows are called periods, and we go 1, 2, 3, 4, 5, 6, 7. The groups are the columns of the periodic table, 1, 2, 3, 4, 5, 6, 7, 8. It's great to know how the periodic table is organised, but actually reading the periodic table is another thing altogether. So over here we're looking at potassium with the chemical symbol of K. So we have the whole name, the whole element name is potassium, but we can shorten that to the chemical symbol, which is K for potassium. Most of the time, those chemical symbols will be just pretty much the first letter of the element name, or it might be the first 2 letters, or a mix of the letters that are in the actual element itself. There are occasions where you end up with multiple elements that have the same starting letters or the same first 2 starting letters, and then a different letter is assigned for that purpose. So for example, potassium is given K because there's other elements that have P or PO or PT, etc. So element name, full name, chemical symbol, how we identify that element. You also have the atomic number. Now the atomic number, like we said before, is how many protons are in that atom for that element. So for potassium, there's 19 protons in the atom. The atomic mass, on the other hand, is the number of protons and neutrons combined. Now, obviously, there's a little rounding because exact 1 proton or 1 neutron isn't exactly 1 in terms of mass. It's 1.000, etc. So there is a little bit of extra, and then you've also got electrons, which are much smaller, and they're also contributing the electron mass, but it's mainly just the protons and the neutrons. So if you're ever asked, what does the atomic mass stand for? It's the number of protons and neutrons inside the periodic table. So for this one, the atomic mass, we have 39. We know that there is 19 protons because it's atomic number 19. If we take 19 away from 39, we're left with 20, so there must be 20 neutrons in potassium. Okay, so atomic number, number of protons in the element, chemical symbol, the letter or 2 letters that we use to represent the element, the full element name, and the atomic mass is the number of protons and neutrons combined in the nucleus of the atom. Moving a bit more into groups, as we've talked about the groups before, remembering that the groups are the ones that are going down along here. So group 1, group 2, group 3, 4, 5, 6, 7, 8. Moving on with the groups. we find that when we're looking at the periodic table, the elements that are in the same group with each other often share the same characteristics. So if we go back over here, helium, neon, argon, they all have the same characteristics. Same as lithium and sodium, same characteristics as each other. Boron, aluminium, same characteristics as each other. The reason for that is because they all have the same amount of electrons in their outer shell. And we're going to talk about that a little bit later when we're actually pulling the atom apart and getting to full year 9 content, not just revision. So there's important groups that you need to know because of the characteristics they share. So group 1, so if we go back to our periodic table, group 1 down here. Group 1 is the alkali metals. The alkali metals, they're shiny, they're soft, you can cut them with a knife, but they're also extremely reactive, and they'll burst into flames or even explode if they come in contact with water because they're so reactive. The reason they are so reactive is because they have 1 electron in their outer shell, and they don't want 1 electron in the outer shell. You want to have either a full shell or none in your outer shell. Okay, so for them, they really want to get rid of that last electron in their outer shell, and we'll talk about this in a lot more detail later on. So they want to get rid of that 1 electron. Group 2, on the other hand, group 2 here, beryllium, magnesium, etc. Group 2 is the alkaline earth metals. Now these are, again, they're very reactive elements, but they're not as reactive as the alkali metals, and that's because they have 2 electrons in their outer shell. Their chemical reactions typically occur more slowly, and they produce less heat than those in the alkali metals, but they are, like I said before, they're still very reactive. Group 7, on the other hand, is our halogens. Now, halogens are quite chemically reactive again, and they're generally going to pair up with the alkali metals to produce various types of salts. Now, again, the halogens, they're so reactive because they have 7 electrons in their outer shell. Now, it gets more complicated than what I'm about to say, really, but for the sake of year 9, an element or an atom is happy when it has 8 electrons in its outer shell. So because they've got 7 electrons in their outer shell, the halogens really want to get that last electron, so they're really reactive to try and get that electron from other atoms and other elements. So they're really reactive. Group 8 is the noble gases. So down here, the noble gases, helium, neon, argon, krypton, etc. With our noble gases, they are completely colourless, they're odourless, and they're almost completely non-reactive. Now, they're almost completely non-reactive because they have 8 electrons in their outer shell. Okay, because I've said before, 8 electrons in their outer shell is happy. They don't want to react because they don't want to lose or gain any more electrons, because then they're no longer going to be happy if they do. Now, if you go back and have a listen to what I've talked about and how many electrons are in each of the alkaline metals, alkaline earth metals, halogens, or noble gas outer shells, you might be able to come up with a reason of why, or of how I instantly knew that the alkaline metals had 1 electron in their outer shells, or the halogens had 7 electrons in their outer shells. If you think you know that, send me an email and say, I think you knew halogens had 7 electrons in their outer shells because of this. I might give merits to the first 2 people that get that right answer in my email inbox. Okay, so moving on a little bit more to the metals and the non-metals. So when we're looking at the periodic table is actually split into metals, non-metals, and metalloids. So metals are basically anything around here, and non-metals over on this side. Metals have several features in common. They're solid at room temperature, except for mercury, which is exception to the rule. Mercury is actually a liquid at room temperature. They can be polished to produce a high shine or luster, so they're quite shiny. They're good conductors of electricity and heat, hence why we use metals for all our wires, etc. in electrical components. They can be bent or beaten into a variety of shapes. We say that scientifically, that they're malleable. They can be made into a wire, so they can be stretched out, which means they're ductile. And they usually melt at very high temperatures, except for mercury again, which melts at negative 40 degrees, which is an exception to the metal rule. The non-metals, on the other hand, there's 22 of these elements that are non-metals, and at room temperature, 11 of those are gases, 10 of those are solid, and 1 of them is a liquid. The solid non-metals have most of the following features in common, so that they cannot be polished, so they're not shiny like the metals. They're very dull or glassy. They're very brittle, so if you hit them, they will break. They can't be bent into shape. They're kind of, whatever shape you find them in, that's kind of what they're in, unless you force it, and again, it will probably break. They're very poor conductors of electricity and heat, so something like rubber, which isn't exactly an element, but it's made up of some of those elements, is not a good conductor, and hence why we insulate our electrical wires with that. And they generally melt at very low temperatures compared to the metals. Unfortunately, though, it's not just metals and non-metals. You also have the metalloids, which are these ones in green in like a little staircase around here. And you remember metals and non-metals because the metalloids are this staircase here. Metals are on the left, non-metals are on the right, except for hydrogen, which is actually a non-metal. So it should really be over here, but we'll ignore hydrogen again for the time being. So metalloids, some of the elements in the non-metal group look like metals. An example of this is silicon. So silicon is actually a non-metal that looks like metal. It can be polished like a metal. It's a poor conductor of heat and electricity, and it can't be bent in or made into wire. Those elements that have these features of both metals and non-metals we call metalloids. There's 8 metalloids altogether: boron, silicon, arsenic, germanium, antimony, polonium, astatine, and tellurium. That's it for that first PowerPoint. There will be a little bit more work on the periodic table on style. If you have any questions, please ask them on Teams or flick me an email. Have a great day.